Hello everyone, this is Priyanka from Edureka, and today we will cover one of the most important topic in machine learning, that is feature selection. Now in the first half, we will cover what is feature selection and its importance with examples. And in the second half, we will cover the practical aspect of feature selection along with implementing various methods of feature selection. And by the end, you would understand how really important feature selection is for the machine learning model. But before we get started, make sure you subscribe to Edureka's YouTube channel and hit the bell icon to never miss an update. Also, if you're interested in online training certification, do check out the link given in the description. So now let's move on to understanding the need for feature selection. Now suppose we've got the student's data set and there are certain features. Now feature here is nothing but columns. So we've got certain columns here, which I will say as features in the entire video. So we've got features or columns like name, marks, address, race, religion, and attendance. Now my objective here is to understand or analyze the performance of the student based on these features. Now clearly we understand that race and religion is something racist and will not contribute towards the performance. So we see that race and religion are irrelevant features here. This is a very simple data set. Now assume that I feed all the features and train the model, which will give me 60% accuracy. And suppose I just train the model giving only the best features, it will give me 80% accuracy. Now this is just with the relevant and the best features that the model give me good performance. We will see how does this really perform well with a practical demonstration shortly. But before that, let us understand that what is really happening in the background. So we are having all the features, that is all the columns. And in feature selection, we are only selecting the relevant and the best features. And we are left with only the final features here, right? Thus, by selecting only the relevant features and training the model based on those features, we get really good results. So now let's move on to understanding what is feature selection. So feature selection is nothing but selecting the optimal and the best features for the machine learning model, right? We give the best to the model so that it gives us very good performance. That is the concept of like garbage in, garbage out. That is here also. We give good, we get good, right? And then we also remove the irrelevant or partially relevant features from the data in feature selection process. So these two things are important, where you select optimal features and you remove the irrelevant features, okay? Based on these two concepts, we will again move on, proceed further and understanding the importance of feature selection. So the importance is that it reduces the curse of dimensionality as we work only with relevant and optimal features, right? So cost of dimensionality is nothing but when you're working with lots and lots of features, lots of columns. So it becomes very difficult in a complex data set. So we remove the irrelevant features and we reduce the dimensionality. Another thing is that it minimizes the cost of computation because we are working with less features. Another importance is it helps in learning the model by providing the best features to the training algorithm. Now, another is that it helps in achieving very good accuracy. So now having said that, let us understand various feature selection statistics. So now in feature selection statistics, we have suppose on x-axis the input variable and on the y-axis the output variable. So these input or output variables could be either categorical or numeric, right? So what happens if our input and output variable are both categorical? Then we will use chi-square test or mutual information. Now, these are the statistical measures or the statistical methods we use in our models when we have got different input and output variables. Now, suppose if your input variable is numeric and your output variable is categorical, we will apply ANOVA or Kendall's rank coefficient. Also, the same statistical measures are being applied when your input variable is categorical and output is numeric, right? So in both these cases, we will apply ANOVA or Kendall's rank coefficient. Now, suppose if you've got both the input and the output variable as numeric, we can apply Pearson's coefficient or Spearman's rank correlation, right? Now, these statistical tools are deployed in the model and it really depends upon the data set that we are working with and the data types that we have in the data. So this is an overall view of the statistics that we will be using in various different data sets, right? To select the best features and train the models. Now, moving on further, we will understand feature selection techniques with hands-on. So in the feature selection techniques, we have supervised feature selection and unsupervised feature selection. And in unsupervised feature selection, we do not require the output or the target variable. Whereas in supervised feature selection, we will require the output or the target variable for feature selection. So there are three methods of supervised feature selection, which is filter methods, embedded methods, and wrapper methods. And we will be covering all the supervised feature selection methods in today's tutorial. So let us understand with filter methods first. So how does filter method actually work? So now suppose there are certain features, or we've got some set of features, and then with this we select some best features, and then what happens is that we feed these features to the learning algorithm, and then we map the performance of this algorithm. This is how feature selection works. Now this technique is really very simple to understand, but what really happens in filter method is that this is just a pre-processing step. That is, we are preparing the data before feeding it to the algorithm, right? And when we prepare the data well, that is, the pre-processing is done very good, we get really good performance and really good results, right? So now filter methods, there are various techniques like information gain. So we will use these techniques in our model to select the best features. One of the technique is information gain. This is nothing but it reduces the entropy, that is the randomness in our data sets. Decision trees, random forests, they can use information gain to reduce the entropy or randomness and select the best features. Now, another filter method technique is chi-square test. Now, this determines the relationship between categorical variables. Another technique, if I talk about, is Fisher's score, which reduces the rank of features in descending order. And based on this ranking, we select the best features. Now, yet another filter method technique is missing value ratio. This evaluates the feature set against the threshold value, and this we set in our data frame. So now let us understand the chi-square test with a hands-on. So what we do here is we will import certain libraries in our Jupyter notebook. We'll import pandas and numpy. Now next we will load the data, and this is the data from this URL we are taking, the PIMA India's diabetes data set. We will read and we will give the features different names, that is the columns. And let us just understand these columns. These columns are nothing but they are just shortened form of preg means pregnancy, plus means glucose, and press is blood pressure, and so on. These are the various features which have been, or the columns which have been renamed, right? And we can see the shape of the data. That is, here we see the shape, that is, we've got 7, 6, 8 rows and 9 columns. And now what we do is we will prepare the data because we have to give it to the filter method, right? So we prepare the data like this, wherein we will separate the X and Y, and in Y we've got the target variable, that is our class. Now here class means 1 means that the person is having diabetes, and 0 means that the person is not having diabetes, right? So we have to predict whether the person is having diabetes or not based on these features. And how do we select the best features so that the prediction is accurate? So this is what we are doing with filter method right now. Now what happens here is that from sklearn, we will import this select k-best. Select k-best is a class which can be used for, multiple statistical tests, and we are using this with chi-square. And we will import this chi-square from feature selection itself. Then we will do certain feature extraction, and we will summarize our score, and also we will print the features which are important. So what we can see here, that we select here 4 features where k is equals to 4, and I run this. And also you can see here that we get various scores here in the first array, and now we set k equals to 4, which that means that we want the best 4 features from this data set, and the highest score features would be selected. So you can see here that the features which is having the highest score would be selected here. So if I can just show you here, this is the highest scoring feature, 111521411.887. The highest score features would be selected. You can see here 2175, this would be selected, this would be selected, and 181. And here is this array, what you see here, this is nothing but we are printing the k features top 5 rows, right? So this is what it is giving me. Now to interpret these features, that means to interpret these, what these numbers are saying, it's simply we can just map it to the columns, right? So we see here that the best 4 features here are plus, test, mass, and age. And they are simply meaning that the glucose level, the insulin, BMI, and age are the best features to be selected for the model. And by selecting all these models, we can train our model and we'll get good accuracy. So based on the scores, the higher the score, the best the feature. This is how K or chi-square tells us the best features. So this was about the filter methods. After having understood filter method, let us move on to our next feature selection technique, that is wrapper methods. So in wrapper method, what happens is that we've got all the features, and this is essentially a search problem. Here different combinations are made, evaluated, and they are compared with other combinations. So algorithms are trained using these subsets of the features iteratively. And what happens is that then based on the output of the model, we select the final set of features. And these features will get the best result. So let me make things a little clear for you by understanding various wrapper method techniques. That is, the first is forward selection. Now, forward selection is nothing but it is an iterative process, and it begins with empty or no features. And after each iteration, it keeps adding on features and evaluates the performance to check whether the model performance improved. And the process continues until a new addition of feature does not improve the performance of the model. So now let's move on to backward elimination. Here what happens is that we start with all the features and we remove the least significant feature at every iteration. And we repeat this until no improvement is observed on removal of features. So this is just the opposite of forward selection. And again, it is an iterative process. Another wrapper method is exhaustive feature selection. And this is one of the best feature selection methods. This evaluates each feature as a brute force. And here the method tries to make each possible combination of the feature and returns the best performing feature set. So as the name suggests, this is really very exhaustive search problem. And then we have got recursive feature elimination. Now this works on greedy optimization approach. And here what happens is that the features are selected by recursively taking a smaller and smaller subset of features. And there are other techniques also like genetic algorithms for wrapper methods. But one thing to note is that these methods are very computationally intensive because it is an iterative process and subsets of the features are being created and they are being again evaluated and the best features are selected for training purposes. So now let us proceed for an hands-on and understand how this wrapper method can be applied in our data sets. So again, we are back in our Jupyter notebook and we will simply import the recursive feature selection from sklearn feature selection. And now we are using here logistic regression. Now any algorithm could be used, and here we are using just logistic regression. I've imported warnings because it gives warning and that doesn't look good. So you can import that if you want, and then we will do certain feature extraction and let's fit this model. So what we are doing is we are printing the number of features that is we have selected. We have selected 3 features and then we have also selected the features as to give the selected features, and it returns a Boolean value that is true or false. And it tells us that first feature is selected, and then we can see that second, third, fourth, fifth, these features are not selected. The 5th and the 6th feature is selected and the 7th is left. The feature selection ranking is also being shown here, and we can see this determines the strength of the feature or the column. So you can see depending on the ranking, we will choose these features. So the first ranking features would be selected for further training of the model. And these features, when we will train the model, we will get really good results. So this is how you select various features. And to interpret this result, we can simply just map these features to the respective columns, right? So preg, this one is the pregnancy. So it has selected pregnancy as one of the feature. It has selected mass, that is BMI. It has selected diabetes pedigree function as important features. So this recursive feature elimination chooses different features or different columns as compared to the filter method, which was giving us different features where we selected 4 features. So now let's understand embedded methods. So now embedded method are nothing but a combination of both filter and wrapper methods, and they create the best subset of features. They combine the advantages of both the filter method and the wrapper methods, and they are more accurate than filter methods. So what happens here is that again it is an iterative process, and as you can see that the models are iterative. They evaluate each iteration and find the most important features that contribute the most to the training in a particular iteration. And what happens here is that the model trains and check the accuracy of different subsets and select the best among them. Okay, so we will make things very clear once we understand the various techniques and apply it on hands-on. So there are various techniques of embedded methods like regularization techniques. We use L1, L2 or elastic nets. So L1 is nothing but lasso and lasso regression, or L2 is called ridge regression, and elastic nets is nothing but a combination of L1 and L2, that is lasso and ridge. So these are embedded methods. And another embedded method is most commonly used, that is random forest for feature selection. These are the tree-based methods and they give you the best features for training your model. Okay, so now let's move on to hands-on and understand the embedded methods. So now let's implement the ridge regression here, which is also known as L2 regularization. So from sklearn linear model, we will import ridge, and by simply importing ridge, we will set the alpha as 1.0, that is 1.0. Now alpha is nothing but it impacts the magnitude of coefficients, and this could range between 0 to infinity. Now we will fit this, and now this is just a helper function to understand and to show various coefficients, and this will really help us to select the best features. So this is a simple function that we have made, and when we just print this function, we get the coefficients here. So the coefficients are shown along with the features, and we can choose essential features based on the value of the coefficients that we get. So x0, x1, x2, these are nothing but our features or the columns, and the coefficients that we get is telling us the importance of the features. So negative coefficients do not contribute much, so they can be ignored. So the higher the positive values, we will select those features. Like suppose here we can select x6, that is 0.145, that is the coefficient value. That means it is a feature which is of importance. And this feature is nothing but this is the mass, insulin. Insulin is one of the another feature that it has been selected here. So insulin, mass, they are important features which we can go ahead and train our model with. So even the wrapper method was also suggesting insulin and body mass, and ridge regression is also selecting those methods. So this is how we employ or deploy these statistical methods, feature selection methods in our data set and extract useful features from it. We select these features to train our model to give us good performance. And we can go ahead with these 3 or 4 selected features and see how our model performs. And this will really give us good results. So this was about the regularization or the embedded methods that we have seen in our data set. Okay, now it's time to understand the advantages of feature selection. So what are the advantages? The advantage of the filter method and the wrapper methods. So let us take it one by one. So filter method is fast and scalable. Also, it is independent of the classifier, right? And as we have seen in our hands-on also. And it has got better computational complexity. It is fast. Whereas in the wrapper method, it minimizes the computational cost, and the model is feature dependent, right? And here it interacts with the classifier. So these are the advantages of both these methods. And the embedded method is nothing but a combination of filter and wrapper method. So it will take the advantages of both. Now moving on to the disadvantages of feature selection. So for the filter and the wrapper method again, so for filter method, there's a little vagueness in filter method actually. That means it is not clear how we determine the threshold point ranking to select only the required features and exclude noises. So we don't know how it is doing it. So there's a little vagueness here. And it also ignores feature dependencies. It also ignores the interaction with the classifiers. So this is somewhere not up to the mark as per the wrapper and the embedded method, which are really exhaustive. And we have seen that it was also giving us different features as compared to the wrapper and the embedded method. So we were getting different results when we applied filter methods, which was actually scratching the surface and which was not going deep and interacting with the classifier and mapping the feature dependencies. But on the other hand, the wrapper and the embedded methods would interact, right? So we have seen one of the advantage also. So the disadvantage is that it has got lower discriminative power, and it has a high risk of overfitting because it will go deep and understand your data. And then it is also computationally intensive. So these methods, they depend on the efficient selection of classifiers for obtaining high accuracy. So this was all about feature selection and how do you really use these methods in a data set. And we've deployed various methods, seen how they have really given us different features and how can we select, train our model and get good results. All right, so this is it from my side, and thank you for watching.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!